anything?
Cores are awesome. Everything that goes into the ocean, either it's washed in from land, it's blown in by wind, it falls out of the sky if it's volcanic ash, if it's the fossil remains of plants and animals that live in the surface water, all of that material falls to the bottom of the ocean. And it accumulates layer by layer, stratigraphically, with the deepest section being the oldest and the top of the sediment being the youngest. And it's like a tape recorder of what went on in the earth through time. I like to think of this one as the crown jewel of the marine geology community, and really is a special place, and it's an incredible collection. One of the original undertakings of Lamont was to study the world's ocean, and this was a huge effort after World War II and the Cold War. So understanding what was in the ocean, how deep it was, underwater mountain ranges were discovered. I mean, crazy stuff, plate tectonics. And Lamont had 2 research vessels. They were at sea all year. They rarely came into port, and these ships were always exploring. And one of the things they always did was core the bottom of the ocean to see what was down there. And all those cores, those tens of thousands of cores, came back to Lamont, where we now archive them here. Probably the most exciting information that scientists were able to extract from cores had to do with the climate history of the Earth. Almost everything we know about how Earth's climate changes through time, naturally, we have learned through the study of deep sea cores over the last few decades. We are a facility funded by the National Science Foundation, and we're like a museum. We have over 40 miles of core from the deep ocean, and we both archive and curate the cores and preserve them for posterity, and we also make samples available to scientists to study. You know, right there, that would be about 1,000 years. That would be 2, 3, 4, 5. So this is like 10, 12,000 years right here. So this is the Holocene. This is the warm period within which human civilization arose.
Wow.
So, yeah. Here we are, we're in one of our lockers. All our VIMA cores are in this locker. VIMA was one of Lamont's first research vessels. I like to think of this as like the big warehouse at the end of the Indiana Jones movie. So, but every number on the end of one of these trays refers to a core number and a specific leg of a cruise from the VIMA. So, you know, we can look at these and pull out exactly what we're looking for. The ships go out, they have a giant winch on a huge spool, and at the end of that winch is a core barrel with a weight on it. So like, think of a huge straw on steroids. And that steel pipe is lowered over the side of the ship. And when it gets close to the bottom, the winch is released and this huge weight drives the core barrel into the sediment. And then we haul the whole thing back up and extrude this core. When the cores come back, the types of measurements that we can do now are just phenomenal. I mean, we can extract organic molecules and measure isotope ratios in them and trace elements of nutrients and all kinds of geochemical fingerprints. As you might imagine, the material that is in these cores, it's very fine. It ranges from the size of fine clay to sand size. So the work you do on the cores often involves a huge amount of time at the microscope. But I love that. I love sitting at the microscope. I could sit at a microscope for weeks looking at the fossils in the cores, organizing them by species, picking out certain ones for geochemical analysis. So, you know, it was just a very zen thing for me. I really enjoyed it. So what's very interesting about the cores is that they come from all over the world. And it's a valuable resource because it's not so easy to get funded to go out to sea anymore. I mean, the real heyday of vast ocean exploration has passed. So many times people want to study a region, they can come and look at existing material rather than have to try to go through some long multi-year process of getting out there on the ship. Why do we have almost 20,000 cores here? I mean, many of these cores were collected for no reason other than like, it was noontime, it was time to take a core. Maurice Ewing, the original director of Lamont, You know, he had the exploration spirit. He says, even if you're out there doing seismology or, you know, some other project, marine biology, I want every Lamont ship to stop every day and take one core, wherever you are. And that was how we built up this incredible collection. That is why, no matter where the ships were, we have a sample of the deep sea floor. Many of our cores have never really been looked at in depth. About half the cores have had, you know, in-depth studies done on them. But many cores really have never been looked at beyond the initial description that was done when they were collected. So it truly is an amazing archive, and every now and then people just strike gold in here and find beautiful records that turn into important scientific papers.
So there are secrets still in here.
There are lots of secrets still in here, yes.